Morning students, today we are going to see application of VBT for the complexes with coordination number 4, 5 and 6. First we see the coordination number 4. Coordination number 4 shows two types of geometries, that is tetrahedral geometry and square planar geometry. So first we are going to see tetrahedral complexes. First example, NiCl4 2 minus. See, in this central metal atom is the nickel. Electronic configuration of nickel is argon core is completed 4s2 3d8. When we see this complex, in this complex Ni have plus 2 oxidation state, that is Ni2 plus. At that time the 2 electrons are removed from 4s orbital and electron configuration for the Ni2 plus is 4s0 and 3d8. It is the valence electron configuration. See, its ground state. In the ground state Ni2 plus there are the 8 electrons in 3d orbital, 4s orbital is empty and 4p orbital is also empty. This tetrahedral complexes undergoes sp3 hybridization. So, in the sp3 hybridization, see, this 4s orbital and 4p orbital, they undergo sp3 hybridization and we have the hybridized state of Ni2 plus. Then, when there is the bonding, at that time, these 4 empty sp3 hybrid orbitals of nickel overlaps on filled orbitals of chlorine and thus there is the bonding state. So here we are going to see the bonding state of Ni in NiCl4 2 minus. See, 3d orbital, it is not taking part into the bonding. Only the valence orbital, that is 4s and 4p, that is the 4 sp3 hybrid orbitals. Here each sp3 orbital overlaps with the filled orbital of the p and filled orbitals p orbital of the chlorine, and it accepts the 2 electrons from each ligand. So first chlorine can donate 2 electrons here, second chlorine can donate the 2 electrons, third chlorine can donate the 2 electrons, and fourth chlorine can donate the 2 electrons. Here we notify that is arrow is equal to the electrons of nickel and cross is equal to the electrons of the chlorine. Thus it is the ground state electron configuration of the Ni2 plus, hybridized state of Ni2 plus, and it is the bonding state. When we see this valence bond theory, that is the VBT picture, shows that in this complex there are 2 unpaired electrons. As there are the 2 unpaired electrons, that means here n is equal to 2. And when we consider its magnetic property, that is magnetic moment can be calculated, we know that as there are the unpaired electrons, this complex is paramagnetic and we calculate the magnetic moment. So we have the formula, that is magnetic moment is equal to magnetic moment mu is equal to under root n in bracket n plus 2. Here n have the value 2. So here mu is equal to under root 2 in bracket 2 plus 2. So is equal to under root 2 in bracket 4 is equal to under root 6, and this will be comes to 2.83 Bohr magneton. Thus this NiCl4 is a paramagnetic complex with magnetic moment 2.83 Bohr magneton. This hybridization shows that it is a tetrahedral. So see the tetrahedral geometry. Here at the center there is the central metal atom nickel and there are the 4 chlorine ligands at the 4 corners of the tetrahedron, and thus there is formation of this tetrahedral NiCl4 2 minus complex. So here is the structure of this complex. See, the second example of tetrahedral complexes is MnCl4 2 minus. See, in this complex, Mn have the atomic number 25, its electronic configuration argon is completed 4s2 3d5. When we consider its oxidation state, here Mn can shows Mn2 plus. So here Mn2 plus oxidation state. Then its electronic configuration 4s0 and 3d5. See, this Mn have the ground state. See, electron configuration of the Mn2 plus in ground state 3d5, 4s0 and 4p0. See, it have the hybridized state. We know this Mn undergoes the sp3 hybridization in tetrahedral complexes. Hybridized state of Mn2 plus, see, 4s orbital and 4p orbitals shows the sp3 hybridization. These orbitals are the empty. See, in the bonding state, Mn undergoes the bonding state. These 4 hybrid orbitals can accept the electrons from the 4 Cl minus ligands, and here we have these are the Mn electrons in 3d orbitals, and these are the hybrid orbitals, sp3 hybrid orbitals. They accept the electrons, 2 electrons from each Cl minus. So here first Cl gives the 2 electron, second Cl gives the 2 electron, third Cl gives the 2 electron, and fourth Cl gives the 2 electron, and thus it can shows the bonding state. When we see the valence bond picture, at that time it is observed that is the V.B.T shows that there are the 5 unpaired electrons. There are the 5 unpaired electrons. In that 5 unpaired electrons, that is the n is equal to 5. As these unpaired electrons are there, this complex is the paramagnetic, and for the paramagnetic complexes we calculate the magnetic moment. So for the magnetic moment, that is magnetic moment mu is equal to under root n in bracket n plus 2. Here n is equal to 5, and now we have the solution, that is 5 in bracket 5 plus 2 is equal to under root 5 into 7 is equal to under root 35. It is equal to 5.95, and it is the Bohr magneton. Thus, this MnCl4 2 minus complex, according to V.B.T, it is paramagnetic with the magnetic moment 5.95 Bohr magneton. This complex shows the tetrahedral geometry. See, in the tetrahedral geometry, Mn placed at the center of the tetrahedron and 4 ligands, they are at the 4 corners. So there is the formation of the tetrahedral self-tetrahedral geometry, 4 Cls at the 4 corners, and we have the particularly this structure here, it having the 2 minus charge. It is the structure of the MnCl4 2 minus. Now we are going to see the coordination number 4. For this coordination number 4, second type of complexes are the square planar complexes. That is, first we see the tetrahedral complexes, and now we are going to see the square planar complexes. See, in the square planar complexes, all the metal atoms undergoes D2sp3 hybridization. Thus, we are going to see the complexes with the D2sp3 hybridization. See the first example, NiCN4 2 minus. This Ni having the atomic number 28, and its electron configuration is argon core is completed 4s2 and 3d8. Then here oxidation state of this Ni in this complex is 2 plus. So we have the Ni 2 plus, and for this Ni 2 plus, 2 electrons are removed from 4s, so it becomes the 4s0, and here there is the 3d8. See now, this Ni in ground state, electron configuration of this Ni in ground state, Ni2 plus, it is 3d8, 4s0 and 4p0. This Ni undergoes here excited state because hybridization is due to sp3, and according to the assumptions of V.B.T, 1d orbital, 1s orbital and 2p orbital must be vacant. So here one of the electron from 3d, it get paired here and it shows the excited state. In its excited state, this orbital is empty, and now it undergoes d2 sp3 sp2 dsp2 hybridization. Yes, dsp2 hybridization. Here 1d orbital, 1s orbital and 2p orbitals undergoes hybridization, and this Ni shows dsp2 hybridization. Then it shows the bonding state. See, these empty hybrid orbitals can accept the electrons from the ligand. Here there are the 4 ligands, and that 4 ligands can donate the electrons into these 4 orbitals. See, here bonding state of this Ni2 plus, bonding state of this Ni2 plus in NiCN4. Here we have the arrow is equal to the electrons of Ni and cross is equal to electrons of the Cl. See these paired electrons, here there are the each ligand can donate a pair of electrons in each orbital, and we have the bonding state. When we observe this Valance bond feature, it clears that there is no any unpaired electron. As there is no any unpaired electron, this complex is diamagnetic. This complex is diamagnetic in nature. That means it has the mu is equal to 0. No unpaired electrons, so that there is the n is equal to 0, and as there is the n is equal to 0, mu value is also the 0, and thus it is the diamagnetic complex. See its structure. When we see the structure of this MnCl4, it is square planar structure. It is square planar structure. Here nickel is at the center, and there are the 4 chlorine atoms. They are coordinated from the corners, and we have the square planar complex of this NiCN4 NiCN4 2 minus complex. See the second example of square planar complexes, CuNH3 2 plus. Here copper is the central metal atom. This copper shows the atomic number 29. Its electron configuration is argon core completed, 4s1 and 3d10. Copper shows +2 oxidation state in this complex. So copper 2 plus have the electron configuration, that is 2 electrons are removed, one from 4s and one from 3d, and its electron configuration will become the 4s0 3d9. See here, electron configuration of this copper 2 plus in ground state, that is 3d9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 unpaired electrons, and 4s orbital is empty, 4p orbital is empty. We know in square planar complexes, central metal atom undergoes dsp2 hybridization. That means copper must have one d orbital empty, one s orbital empty, and two p orbitals empty. Now see in the excited state, here in the ground state there is one electron in the orbital. So it must be promoted in this empty p orbital, third empty p orbital, and it shows the excited state. So in the excited state, one of the electron will be promoted from 3 into 4p, and we having this picture. That is one electron into this, and then this d orbital, s orbital, and these two p orbitals undergoes hybridization, shows dsp2 hybridization, dsp2 hybridization. Then it shows the bonding. In the bonding structure, see these empty orbitals, they occupied by the electrons from the ligand. They accept the electrons from the 4 NH3 ligands. And see here, first NH3 can donate 2 electron, second NH3 can donate 2 electron, third NH3 can donate 2 electron, and fourth NH3 can donate the 2 electron. And here the orbital, p orbital, which is not taking part into the bonding, it has a single electron in it. And when we see this picture, it is the bonding picture. See this particularly arrow is the electrons of the copper here also, and this cross is the electrons from the NH3 ligands 1, 2, 3 and 4. So it is the bonding picture. But we see this valence bond picture, it indicates that there are 1 unpaired electrons, and so that this complex is paramagnetic. It have the magnetic moment, and we have the formula for the magnetic moment, that is magnetic moment mu is equal to under root n in bracket n plus 2. Here n is equal to now 1, and so that this formula, by filling the value of this, it is equal to 1 in bracket 3 under root. So it is equal to the 1.73, and unit for this is the Bohr magneton. Thus, CuNH342 plus is a square planar complex with hybridization dsp2. It is paramagnetic complex with one unpaired electron, and magnetic moment is 1.73 Bohr magneton. When we see the structure of this complex, see of the structure, we know its geometry is the square planar. Here metal atom and all ligands, they are in the same plane, and so that here there is the first NH3, second NH3, third NH3 ligand, and fourth NH3 ligand. This complex have the 2 plus charge, and so that it is the plus 2. So it is the CuNH342 plus complex. Thus, we have the valence bond presentation of this copper complex CuNH342 plus, which is the square planar complex.